In this video, I'm going to take you through the solution to a typical problem on projectile motion. So let's see. The question is, a rocket is fired straight up in the air at a fireworks display. When it reaches a height of 28 meters, so you should keep highlighting what is given to you. So it says when it reaches a height of 28 meter. So this should be considered as initial displacement. Yeah, so our initial displacement vector will come out of this and it explodes and the empty shell is projected. So it's a projectile motion we are talking about at an angle of 60 degrees. So this will be our initial angle, theta I, to the horizontal with a speed of 30 meter per second. So that's the initial velocity, I should say. So that will be Vi vector will come out of this. How long? That means it is asking for the at what time t will it take for the shell to fall back to the ground after the rocket explodes. So neglect a resistance and take g. So we have acceleration, and in this case acceleration is equal to acceleration due to gravity, and that value is given by 10 meter per second square. So in part A, we have to find out the time at which it hits the ground. And the time is calculated from the time since the explosion of the rocket. And in part B, how far? So that means again, we have to find out the displacement. How far will the shell land from its launching site? Let me take you through the graphical explanation. So let's try to understand the question graphically. So here I have drawn the projectile path. So let's assume that this point A is the point at which the rocket explodes. And as we see clearly, A is given to be 28 meter above the ground. So what is given is the initial displacement or position will be derived out of this height, 28 meter. If I say this is my x-axis and also the direction of the unit vector I, and this is my y-axis, this is also the direction of the unit vector j. So when the rocket is fired, it is fired with a initial velocity. So I can write this as vi vector will be made out of this with the magnitude 30 meter per second. And the direction is given as 60 degree, which will be theta I. And so those are the inputs provided. And what is the output required? What exactly is need to be calculated? Let's say after some point of time, let's say at some point t equal to t. And also one more important thing I forgot to mention here, that I will consider this as t equal to 0 at the time of explosion or the firing of the projectile. And t equal to t is the time which we have to calculate at which it hits the ground. At point P, what will be the time at which hits? And also we have to calculate in part B the length OP, the horizontal length or horizontal displacement, we can say. So the first thing we have to calculate or we have to derive is the expression for the velocity. And for that, we have to start with the expression for the acceleration. So acceleration can be written as minus g times j. So this will be vector A, which is the acceleration, will be equal to minus g, acceleration due to gravity, times unit vector j. So when a projectile is during the parabolic path of the projectile, it may not be a very good handwriting, I think, but it should still explain the concept. At any point of time during the flight on this parabolic path, the acceleration will always be acting vertically downwards. And the magnitude of the acceleration that is given is 10 meter per second square. And since it acts in the negative j direction, so we put it as A equals to minus gj. And let's put the value here. So it'll be vector A will be equal to minus 10 vector j. So henceforth, I will not be using the word vector. It is implied. When I say A, it should be interpreted as vector A. And when I say J, it should be interpreted as unit vector J. So if you remember the expression, acceleration is given by rate of change of velocity with respect to time. Yeah. So I'll keep writing in the vector notation form. And if I just change the sides, I can also write it like this, that the time derivative of the velocity will be equal to the acceleration. If I consider this as in the denominator as 1, and then I do a cross multiplication, so I will get something like dv will be equal to a times dt. Now, to be able to find v from dv, we have to do the integration. And here I'm going to make use of the concept that integration of the differential is always equal to the variable itself. There will also be a constant of integration, which I'm not writing because it's just a concept I'm explaining. So using similar logic, integration of dv will be equal to v. So from here, if I put integration on both sides, it'll be integration of dv will be equal to integration of a dt. And this can further be simplified as this will be the velocity that will be equal to, put the value of a over there. A is given as minus gj, yeah, times dt. And how do we solve this integration? So we have to take all the constant terms out. So minus g will come out. Anything else that can come out? Yeah, so j will also come out, and this will be integration of dt. So as I explained earlier, if using the same concept like this one, integration of dt will be equal to t. Yeah. There will also be constants of integration over here. For example, there will be C1 here, there will be C2 here, and there could be C3 over here. So we will not go into that as I'm going to explain shortly. So finally, what we get is velocity v will be equal to minus g j t plus c. So c is the constant of integration. Now, the next step is we have to determine the value of c. So how can we determine the value of c? So let me call it as, let's say, equation number 1. Yeah. In equation number 1, if I analyze the equation 1 at time t equal to 0, that is when the rocket was fired at the given height. So at time t equal to 0, this equation number 1 will give velocity will be equal to the initial velocity. Yeah. And let me put this condition into the equation 1, and therefore I will get initial velocity will be equal to, this becomes t is 0, so that the expression, that whole term will be 0, and this will be c. So what we have found out just now is that the constant of integration c is nothing but equal to the initial velocity. Now, if you see what was given in the question was that the projectile is fired with a initial velocity magnitude of 30 meter per second, and it was fired at an angle of 60 degrees, right? So we have to translate this in the form of the vector notation, and this can be written as velocity initial will be equal to vi, if I consider this as vi, yeah. So this will be vi cos theta I, which is this one, times I plus vi sine theta I j. So how we read this as the initial velocity will be given as the horizontal component of the velocity plus the vertical component of the velocity. Yeah. So if we just substitute the values, so what do we get? We get vi will be equal to 30 cos 60 times I plus 30 sine 60 times j. And if you remember the values for cos 30, I remember it like this: cos 60 is same as sine 30, and sine 30 is half. Yeah. So this will be 30 times half times I. And what is sine 60? Sine 60 is root 3 over 2 times j. So can we simplify this further? Yeah. So let's do as much simplification as possible. So this will be 15 I plus 15 root 3 j. So let me call this as equation number 3. So we have from equation, if I combine equation 1 and 2, equation number 2, which gives vi equals to c, and then we also have equation number 3, which also gives vi. Yeah, so since both of them give vi, so that means I can make equation 2 should be equal to equation number 3, and that should give me the value of c. So that will give me c will be equal to 15 I plus 15 root 3 j. Yeah, so but that's the value of c. What we need is ultimately the value of the velocity. So let me call this as number 4. Yeah. So what do you think if I put 4 in equation number 1? So that should give me the expression for the velocity. So if I put equation number 4 in equation number 1, what do we get? So we get velocity will be equal to minus g, and the value of g is given as 10 j t plus c, and c is nothing but equation number 4. So just put that value. This will be 15 I plus 15 root 3 j. So what we have done so far is we have found out the value of the velocity, which we are going to use it in the next set of equations. So let me call it as number 5. Yeah. So now the thing is, if you remember in the question, we have been given the initial displacement and we have not made use of that. So what we have done so far, we started with the general expression for the velocity, and then we found out we have made use of the initial velocity, and then this is our equation so far for the velocity. So now the next step is to do similar steps for the displacement. So as you may already know, velocity is given as rate of change of, I can put it as time derivative of the displacement. Yeah. And if I just interchange the sides, so I can as well comfortably write it as ds over dt. This is read as time derivative of the displacement will be equal to the velocity. And let's say in the denominator, I can consider it as 1, and I can do a cross multiplication. Yeah. So this will be ds times 1 will be equal to v times dt. And then, of course, I can do the integration on both the sides. Yeah, I can do the integration on both the sides. So if you remember, integration of the derivative of a variable will be equal to the variable itself plus a constant of integration. So I'm going to make use of that. Using that, it will be, we get displacement will be equal to v, integration of v. So we make use of equation number 5. Yeah. So that will be minus 10 j plus 15 I plus 15 root 3 j and times dt. So this should be considered as a integration made up of 3 terms. So this is my term number 1, this is my term number 2, and this is my term number 3. So I need to separate the integrals. So therefore, the displacement will be given by integration of minus 10 jt dt plus the integration of the second term, which will be 15 I dt plus the integration of the third term, which is 15 root 3 j dt. So we take all the constant terms out. So minus 10 will be out, and j will also be out, and this will be integration of t dt. Yeah. Plus over here 15 will be out, and then I will also be out, and this will be integration of dt. Plus in the last term, it will be 15 root 3, which is a constant, will be out, and then j will be out, dt. This will be equal to, so we are required to find what's the integration of t dt. So if you recollect, integration of x to the power n dx is given as x to the power n plus 1 over n plus 1 plus a constant of integration. So if you apply the same logic with t dt, so I can consider it as, let's say, tn dt will be equal to t to the power n plus 1 over n plus 1. And what's the value of n given in the question, in the expression? So we have t power 1. T power 1 dt will be, if you put n equals to 1, this will be t square over 2. Yeah. So let me write over here. This will be minus 10j t square over 2 plus 15I. Integration of dt will be t, as I explained earlier, plus 15 root 3 j t. Now we put overall for all the complete integration another constant of integration. Let's call that as d. Yeah. So let's try to rearrange the terms. So we try to simplify as much as possible. This is 2 and this is 10. So this will be 5. So if I put all the I terms together and j terms together, so the displacement will be given by, this will be 15 ti negative, this will be 5 t square j plus 15 square root of 3 tj. Yeah, this I can further simplify to make it look better. So this will be 15 tei plus, in the bracket, I'll write this as minus 5 t square plus 15 square root of 3 t times j plus d. And since constant of integration will also be a vector, so I should have ideally written here for all constants of integration with the vector symbol. Maybe let's call it as equation number 6. Okay, equation 6 at time t equal to 0. So at time t equal to 0, the displacement will become the initial displacement. So displacement will become initial displacement, and therefore equation 5 will reduce to, or it will become, initial displacement will be equal to, this term will be 0, this will be 0, and this will also be 0. So that will be d. So d will have the value of initial displacement. And is that given to us? Let's see. So maybe I call it as 7. Yeah. And in the question, it is given that the initial displacement, it is the rocket is fired from a height of 28 meters above the ground. So how you can write the initial displacement? I can write it like this. So there is no I component over there. So it will be simply 28j. Yeah. So it's above the ground. So I'd consider it as along j. So maybe I call it as number 8. Yeah. Therefore, 7 and 8 represent the same thing, which is the initial displacement. So 7 equal to 8, it will give me what? It will give me the value of d, and that d is equal to 28j. Yeah. So I can go on numbering. I like to do the numbering, so, but don't get confused with so many numbers. I think it is pretty straightforward to understand. Maybe I'll call it as number 9. Yeah, equation number 9. So if I put equation number 9 in equation number 6, so I will get the displacement. So that will give me displacement will be equal to 15 ti plus minus 5t square plus 15 root 3 t. And then let me also, in the same step, put the value of d, which is 28. 28 times j. Yeah, so that's my target equation, which will help me to come to the solution of the given parts A and B. So let's see what has been asked in A and B. So for the part A, how long will it take for the shell to fall back to the ground after the rocket explodes? So we have to find out what's the value of the time t. Okay, and when the projectile is at point P, what do you think will be the y component value for the displacement? So on the x-axis, all the y values will always be 0. So when it hits the ground at point P, the y component, or I should say the j component, should be 0. Yeah. So j component should be 0. So which means in equation number 10, this part should be equal to 0. Let's put that condition and try to find out the value of t. So this will be minus 5t square plus 15 root 3 t plus 28. This should be equal to 0 at point P. And how do we solve this? So this should be familiar and should be compared with the quadratic equation. The quadratic equation, the general form is ax square plus bx plus c is equal to 0. Now, if you compare these two expressions or equations, you will get a should be equal to minus 5 and b should be equal to 15 root 3. Yeah, and what should be c? So c should be 28. Yeah. The solution to the quadratic equation is x equals to minus b plus or minus square root of b square minus 4ac over 2a. Yeah. So you have to put these values. So let's put the values. So minus b will be minus 15 root 3 plus or minus square root of b square. So 15 square will be 225 and root 3 square will be 3. So this is b square minus 4 times a. A is minus 5 times c, that is 28 over 2a, that will be minus 10. So if you solve with the calculator, you will get different values. So that will be t values will be, since it is quadratic, so there should be two values. So t values are negative 0.91 and maybe I call it as t1 and t2, which is 6.1. Now we know that time cannot be negative and therefore this value is ruled out and therefore there is only one value for the time. At time t equal to 6.1 second, the ball or the projectile will hit the ground after it has exploded. So explosion happens at time t equal to 0 and 6.1 seconds later it will hit the ground. And now let's see the part B. How far will the shell land from its launching site? So we have to find the displacement OP. So displacement OP is given by equation number 10. At that time, at point P, this will be 15 t, so which we have calculated as t2 times I. Yeah. So just put the value of t2. So it will be 15 times 6.1 I. So in terms of the distance, it will be 91.5 meters.